Hello everyone, welcome back to Statistician's World. In today's video, we're diving into a special request from one of our subscribers. She wanted a video on Quade's ANCOVA. Quade's ANCOVA, which is also known as the nonparametric analysis of covariance, is a very useful technique in statistical analysis, although it is less known compared to the ANCOVA. So here is what we'll cover today: what Quade's ANCOVA is, when to use it, the assumptions behind it, how to interpret results, and finally, I'll answer the subscriber's question, Farna's question about multiple covariates. So let's get started. First, let's start with the basics. Quade's ANCOVA is a ranked-based nonparametric alternative to ANCOVA. But why do we need this technique? Because traditional ANCOVA assumes normality of residuals, homogeneity of variances, and linearity. But what if those assumptions are violated? For example, when your data are skewed, ordinal, or have outliers. That's where Quade's ANCOVA comes in. And here is how it works. Instead of using raw scores, Quade's ANCOVA works by ranking the residuals after adjusting for covariates and then testing group differences using those ranks. So here is a small example on how to rank the data. The dependent variable is test score. Independent variable or groups are teaching methods of A, B, and C. And the covariate is the hours studied by students. So we wanted to know if there is a difference between these teaching methods and the test scores of a student, considering the hours each student studied before the test. So in step 1, we adjust dependent variable for covariate. To do that, we regress test score on hours studied. So suppose the regression line is something like this: y hat equals 70 plus 3 multiplied by hours each student studied. This gives us the predicted test score for each student. For the first student, let's calculate the y hat, or the predicted test score. The hours studied by student number 1 is 5 hours. So y hat would be 70 plus 3 multiplied by 5, which gives us 85. So the predicted test score for student number 1 would be 85. In step 2, we compute residuals. Residuals equals actual test score minus predicted test score. So, and here you can see them for all of the students here. And in step 3, we rank the residuals from lowest, most negative, to highest. And finally, in step 4, you apply the ANCOVA logic on these ranks instead of on the raw data. So that's the essence of Quade's ANCOVA. Adjust for covariates, rank the residuals, and then compare groups. Now, I think we know when to use this method. Use it in a scenario that you have a continuous dependent variable, at least one categorical independent variable like groups or treatments, a covariate that you want to control for, and your data violated ANCOVA's assumption, especially the normality and homogeneity of variances. In our example, we compare test scores across teaching methods while controlling for hours of studying when the test data were skewed or ordinal. Before doing the test, here's another important thing that needs to be considered. Even though Quade's ANCOVA is non-parametric, it still has some assumptions you need to know. First one is that the covariate must be measured before the treatment and not influenced by it. Like obviously in our example, the hours studied by each student was before taking the test. So this assumption is met. The next one is that the relationship between the covariate and the dependent variable should be monotonic. It doesn't necessarily mean that it should be linear, but they should be in one direction. And the third assumption is that groups must be independent. Like in our example, teaching method were completely independent and they have no effects on each other. And finally, the dependent variable should be at least ordinal so that it can be ranked. Notice what's missing here There is no assumption of normality, and there is no assumption of homogeneity of variances. These assumptions rarely happen in real world, so that's what makes this technique a very powerful tool in messy real world data. And finally, now we want to know how to interpret the results. Good news is that interpreting Quade's ANCOVA is similar to interpreting ANCOVA, just non-parametric. For our example, the different teaching methods effect on test score, you'd write something like this. A Quade's ANCOVA was conducted to examine teaching method differences in test score while controlling for hours studied. Results indicated a significant effects of teaching methods based on the F statistic and p-value. They suggested that after adjusting for hours studied, methods differed significantly in test score. But if the results were non-significant, you'd say something like this. After adjusting for hours studied by a student before the exam, no significant differences were found between methods of teaching and test score. Now we're done with the Quade's ANCOVA. So let's answer my subscriber's question. The question was, does Quade's ANCOVA work when we have more than one covariate? This is an excellent question, and here is the answer. Quade's ANCOVA was originally designed for one covariate. That's the clean classical version. You adjust for a single variable, rank the residuals, and compare groups. But if you have multiple covariates, it becomes trickier because Quade's didn't define it that way. To solve this in practice, statisticians have developed rank-based general linear models that follow the same spirit as Quade's idea, but allow multiple covariates. These models are implemented in R packages like NParLD and AR tool. You can use them and do the analysis when you have more than one covariate. So the short answer is, if you stick to the classical Quade's ANCOVA, it's best when you have one covariate. But if you need to handle more than one covariate, you'll need to use modern rank-based ANCOVA methods instead. Right? That way you're staying true to the spirit of Quade's ANCOVA method, but with the flexibility to handle more complex designs. So, to recap today's video, Quade's ANCOVA is a non-parametric alternative to ANCOVA. It is useful when assumptions of parametric ANCOVA are violated. It controls for one covariate using rank-based residuals, and for multiple covariates, you'll need more advanced non-parametric ANCOVA. So that was it. As always, thanks for watching. I hope Farnaz got her question answered. And for the rest of you, if you found this video helpful, give it a like, subscribe for more tutorials, and let me know in the comments if you'd like me to demo Quade's ANCOVA in R in the future. See you in the next video.